we know that 4 squared is 4 times 4. But what is 4 to the 1/2 power? Well, 4 to the 1/2, when the 2 is in the denominator here, instead of treating it as a power, it's a root. In this case, the square root. So what we want to know is what number multiplied times itself twice gives me 4. So in this case, the answer is 2. In this case, it's 16. 4 times 4 is 16. Here we say the square root of 4 is 2 because 2 times 2 is 4. Now, we know that if we take the square root of something and square it, we get what's inside, because this is the square root of 4 times the square root of 4, which is the square root of 4 squared, which is just 4. But let's think about how this would look if we did it with rational exponents. We could say 4 to the 1/2 squared, since the square root of 4 is 4 to the 1/2. Well, when we raise a power to another power, we multiply the exponent. So this would be 4 to the 1/2 times 2. 4 to the 1/2 times 2 is 4 to the 1st, which is 4. So using rational exponents is another way to work with radicals. And sometimes it's easier than working with the radicals themselves, because then you just have to remember how you work with exponents. And instead of learning 2 sets of rules, basically you're just applying exponents in a different way. So a to the 1/2 is the square root of a. So what's a to the 1/3? Well, this is the cube root of a. In other words, this one is saying what times what equals a, and this is saying what times what times what equals a. In other words, what would I have to multiply times itself 3 times to give me a? Now, if we do a to the 1/3 squared, that is the a to the 1/3 times 2 power, which is a to the 2/3 power. So notice in the numerator we have the power, in the denominator we have the root. So if we were to write this in radical form, this would be the cube root of a squared. Now, how else could we, now what if we did a squared to the 1/3 power? Well, this would be a to the 2 times 1/3, which would also be a to the 2/3. So we could also say this is a squared and then take the cube root of that. So notice these two are equal to each other because they're both equal to a to the 2/3. I can say the cube root of a squared or the cube root of the quantity a squared, and they're the same thing. Sometimes it's more, depending on what the numbers are, sometimes it's more useful to write it with the radical in the parentheses raised to the power. Sometimes it's more useful to raise the number to the power first before applying the radical. So let's do some practice on this. Write using a rational exponent and simplify. In other words, write using a fractional exponent. So remember, the numerator is the power, the denominator is the root. So this would be x to the 3/4 power. Numerator is the power. The denominator is the root. One more thing about roots. Notice that there's no number on a square root. The square root is the smallest root you can have. So that's just assumed to be squared. Just like when we write x or 2x equals 3, we know it's 2x to the 1st power, but we don't write x to the 1st. We just assume a 1. Here we assume a 2. So this is a square root. There would be an assumed 2 here. Now we have a negative exponent. So the first thing we're going to do is take the reciprocal of the base, which would be the square root of x over 1, and raise it to the positive 4. Then we know that the exponent applies to both the numerator and the denominator when we're dividing. So this would be the square root of x to the fourth over 1 to the fourth. Well, 1 to the fourth is just 1, so I don't need to deal with that anymore. And then the square root of x to the fourth could be written as x to the 1/2 to the fourth power, which is x to the 1/2 times 4, which is x squared. Now, could I have done the square root of x times the square root of x times the square root of x times the square root of x and come up with x squared? Certainly, I could have done that. This is just showing how you can use rational exponents to help do something maybe a little more efficiently. Now, sometimes it's helpful to go back to radical form to simplify something. So if I have x to the 2/3, I can write this either as the cube root of 8 squared or the cube root of 8, the quantity squared. So in the first one, I would have to first find what 8 squared is and then take the cube root of that. Or here I would take the cube root of 8 first and then square it. The second one's actually easier because probably most of you know what the cube root of 8 is. What number multiplies times itself 3 times to give you 8? Well, it's 2, because 2 cubed is 8. So if I'm looking at the second one here, I could say this is the cube root of 2 cubed squared, or 2 squared, which is 4. Because all of this inside the parentheses just equals 2. Okay. Next one, I have 4 to the negative 5/2 power. So let's write the reciprocal and write it to the positive 5/2 power first of all. Then I have a power of 5 and a root of 2. If I have a root of 2, that's a square root. So I'm going to say the square root of 1 over 4 to the 5th power. Well, when I have the square root of a fraction, I can think of the square root of the numerator and the denominator separately. Sometimes that's helpful. So I could say the square root of 1 over the square root of 4 to the 5th power. Well, the square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2. So I have 1/2 to the 5th power. So that's 1 to the 5th over 2 to the 5th. 1 to the 5th is just 1. 2 to the 5th is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 1 over 32. So when I say write in radical form and simplify, then I want to simplify as much as possible. Now sometimes when you write in radical form and simplify, you're going to still have a radical in your answer. Okay, so if this had been the cube root of 4, for example, instead of the cube root of 8, I wouldn't have been able to simplify that any farther. So in some of your homework problems, you'll have a radical still in your answer. Now, rules about radicals. Many of you have forgotten how to work with radicals, and there are a lot of careless mistakes that are made with radicals. So I want you, first of all, just to maybe turn off the tape for a minute, or turn off the video, or pause the video, and try to figure out whether these are true or false, and just take a couple minutes, and then unpause your video and see if this is true or not. Tip is use rational exponents instead of radicals, and you'll be able to determine the answer correctly. The first one is true, and the reason it's true is because I could rewrite x squared y squared, the square root of x squared y squared, as x squared y squared to the 1/2 power. And then I know that because x squared is multiplied times y squared, the 1/2 distributes over multiplication. So this multiplies and this multiplies. So I have x to the 2, so I have x squared to the 1/2 power, or x to the 2 times 1/2, times y to the 2 times 1/2, which is x to the first, y to the first. So xy. Actually, I don't need to write that last step. Okay. Second one. This is the same as x to the 1/2 plus y to the 1/2. Well, what do I do with exponents when I add the bases? I can't do anything. The bases aren't the same and they're not multiplied together, so I can't go any farther with this. What is this over here? This would be x plus y to the 1/2. Am I allowed to distribute the 1/2 over addition, an exponent over addition? No, you can't. So these two are not equal, and this is a false statement. I'm actually not doing these in order, but I'm going to keep going downward. No, I guess I'll go to number 2. What about x squared plus y squared? Does that equal x plus y? Okay. Well, many students think that this is a true statement, but let's put this in terms of exponents. This would be x squared plus y squared to the 1/2 power. Does that equal x plus y? So can I distribute and say that x squared to the 1/2 plus y squared to the 1/2? No. This is not, I cannot distribute. So I cannot distribute this exponent because it's being distributed over addition. And we know that's not allowed. Okay, shoot, I can't fit that on there. Let me see if I can scoot this over here. There we go. Now I can finish writing that. We cannot distribute this exponent. And same here. If we go the same thing applies for number 3. Okay, number 4. The square root of x times the square root of y equals the square root of xy. Well, this is x to the 1/2, and this is y to the 1/2, and they're multiplied. And this is xy to the 1/2. So what I'm asking is, can this exponent distribute over the x and the y? Well, the answer is yes. We know that an exponent can distribute over multiplication, so this is a true statement. Oh, this one was false. Number 2 was false. Number 5, the square root of x times the square root of x. Well, this would be x to the 1/2 times x to the 1/2. Well, x to the 1/2 times x to the 1/2, since that we have the same base, this would be x to the 1/2 plus 1/2, which would be x to the first, which is just x. Does x equal the square root of 2x? No, it does not. This would be false. Now, if I had which you might have gotten mixed up is, what if I had, well, let's go to the next one actually. If I have the square root of x plus the square root of x, well, I have 2 of them. So that's the same as 2 times the square root of x. Is that the same as the square root of 2x? Well, the square root of 2x is the square root of 2 times the square root of x, and the square root of 2 is not 2, it's the square root of 4 is 2. So these are not equal to each other. So this is false. So I didn't actually need rational exponents for this, but if I had put rational exponents in, I would have had x to the 1/2 plus x to the 1/2. Well, if I add 2 identical items, I will have 2 of them. This is 2 times x to the 1/2. But only the x has the 1/2 on it, not the 2. So this is 2 times the square root of x. So you could also look at it that way. So sometimes using rational exponents and remembering how the distribution rules and the addition and multiplication rules for exponents will help you with radicals as well.